Hello everyone, welcome to today's class. We will learn about the start, up and shutdown operations of centrifugal pump. Before introducing the start-up and shutdown operations of a centrifugal pump, we need to first understand two abnormal phenomena of centrifugal pumps, air binding and cavitation, and the characteristic curves of centrifugal pumps. When there is air inside a centrifugal pump, due to the very low density of air, the rotational centrifugal force is also very small, resulting in insufficient vacuum at the pump inlet, which prevents the liquid from being sucked into the pump. This phenomenon, where the pump operates in a dry run condition and fails to deliver liquid, is called air binding. Therefore, the pump must be primed and vented before starting. To avoid air binding, cavitation is the phenomenon where the transported liquid vaporizes and then reliquefies inside the pump as the liquid flows through the pump. If the pressure at a certain local point equals or falls below the vaporization pressure of the liquid vaporizes at that point. After vaporization, a large amount of gas escapes, forming many small bubbles. These bubbles flow with the liquid from the low pressure zone to the high pressure zone, where they collapse under high pressure, creating instantaneous local cavities. The liquid rushes into these cavities at extremely high velocity and continues forward, generating tremendous impact forces. Repeated occurrences of this process cause damage to the inner surface of the pump, casing, and the impeller, starting from pitting to a honeycomb state, and eventually leading to the erosion of the material wall. The root cause of cavitation is that the pressure at the suction inlet is less than the saturated vapor pressure of the transported liquid. Under operating conditions, external causes of cavitation include excessively high temperature of the transported liquid, excessive resistance in the suction pipeline, and excessive installation height of the centrifugal pump. Therefore, during the startup of a centrifugal pump, it is essential to ensure that the pump inlet is completely unobstructed. That is, the pump inlet valve should be fully open. The characteristic curves of a centrifugal pump include the head flow curve, shaft power flow curve, and efficiency flow curve. From the head flow curve, we can see that as the flow rate increases, the head of the centrifugal pump decreases. The flow rate can be zero, indicating that the pump can operate with a closed discharge valve. That is, the inlet valve is fully open and the outlet valve is closed while the motor is running. From the shaft power flow curve, we can see that as the flow rate increases, the shaft power of the centrifugal pump increases. When the flow rate is zero, the shaft power is at its minimum. Therefore, during the startup of a centrifugal pump, to prevent overheating of the motor windings, the outlet valve should be closed to reduce the starting current, thereby lowering the power and protecting the motor. After start-up, the outlet valve should be gradually opened, meaning the centrifugal pump should start with a closed discharge valve. From the efficiency flow curve, we can see that the pump's efficiency initially increases with the flow rate reaches a maximum and then decreases as the flow rate continues to increase. It is important to ensure that the pump efficiency does not fall below 90% of the maximum efficiency to reduce energy consumption. Next, we will watch a video on the start-up and shutdown operations of a mechanical seal centrifugal pump. Operation of mechanical seal centrifugal pump. First, let's introduce some basic components of a mechanical seal, mainly including the rotating ring, stationary ring, spring, etc. The stationary ring is fixed on the pump casing seat, while the rotating ring rotates with the shaft and the spring presses against the rotating ring. Mechanical seal flushing is divided into self-flushing and external flushing. The functions of mechanical seal flushing are: first, to form a sealing, lubricating liquid film between the rotating and stationary rings of the mechanical seal. Second, to flush away particles and debris between the rotating and stationary rings. Third, to cool the friction heat generated between the rotating and stationary rings. Next, we will perform the start-up of a mechanical seal centrifugal pump. First, check the integrity of the anchor bolt connections and ensure there is no looseness. Then check the oil level through the oil cap. The oil serves the purposes of lubrication, sealing, and cooling. The oil level should be between 1/2 and 2/3. If the oil level is insufficient, add oil through the oil cap, not through the oil cup. Second, open the protective cover and manually rotate the coupling to check if the rotation is smooth and uniform, and listen for any abnormal sounds. Generally, rotate 5 times. Third, open the mechanical seal flushing water valve. The flushing water pressure should be around 0.2 megapascal to ensure the flushing water functions effectively. Fourth, fully open the inlet valve to prevent cavitation. Fifth, open the pump vent valve to vent the pump, ensuring the pump is filled with liquid to prevent air binding. Sixth, start the motor. During pump startup, keep the outlet valve closed to minimize the starting power, reduce the motor starting current, prevent instantaneous motor overload and burnout, and avoid backflow. Seventh, gradually open the outlet valve and adjust the valve opening to the desired flow rate, such as 5 cubic meters per hour. Eighth, observe the pump inlet and outlet pressures. Ninth, listen for sounds and feel for vibrations to check for any abnormal noises or vibrations. 10th, after some time, check the temperature of the motor and bearings. When checking the motor temperature, use the back of your hand to touch it. At this point, the centrifugal pump is in normal operation. Shutdown of a mechanical seal centrifugal pump. First, close the centrifugal pump outlet valve. Second, turn off the centrifugal pump motor and ensure the pump does not reverse. Third, close the inlet valve. Fourth, close the flushing water valve. Fifth, open the drain valve to discharge any residual liquid from the pump. Through this lesson, we have mastered the 2 abnormal phenomena of centrifugal pumps, air binding and cavitation, the characteristic curves, and the start-up and shutdown operations. Next, we will consolidate the knowledge learned today through a few exercises.